And so, we're doing SAT today, I take it?
Yes, please.
Okay. You're here in Denver, aren't you?
No, we're actually in Monument.
Oh, that's worse. Boy, I bet
Yeah,
you guys get hit by the storm pretty bad?
yeah, we did. We definitely got 2 days off of school, which was really nice. And there's drifts that are over the fence in the backyard.
Wow, wow. We got hit hard. Well, not really. We only got like 8 inches of snow, but the winds did quite a bit of damage.
Oh yeah, definitely the wind. We lost power for a little bit yesterday too, I
Yeah,
think.
I was in the middle of tutoring and I lost internet access, I lost TV access, and I lost phone. You talk about.
Wow.
But other than that, there wasn't a lot of damage here.
Yeah, not at all.
Okay, I got where we left off, and correct me if you have better information, but we were doing test 2, number 19, about a month ago.
Yes, that is the last one I have.
Okay. So that means we must have done 19.
Uh-huh.
Okay, let's start with 20. Let me, first of all, blow this up a little bit so I have lots of white space to write on. All right. First of all, yeah, go ahead. If you know how to do this, I won't elaborate. But if you don't, I want to say a few things about this.
Okay. Yeah, I would definitely like to hear what you have to say about this one.
All right. Let me bring up this. Give me a little writing room. There are basically 3 scenarios. Okay. One where you have a solution. If I had x minus y equals 5, and I have x plus 2y equals 3, well, I can solve.
Mhm.
When I solve, I'm going to subtract the 2 equations, so the x's go away. And then I have minus y minus 2y, so I have minus 3y equals 2. So y equals negative 2/3. Once I have a y value, I can plug it into the simplest equation and solve for x.
Okay.
Most of the time, when you have a system of simultaneous equations, this is the answer. You have a specific solution for x and y. Sometimes you have an infinite number of solutions. If I say x plus y equals 10, how many solutions are there?
Infinite.
Yeah, x can be 1, y can be 9, x can be minus 1, y can be 11. Obviously, I got an infinite number of solutions. So if I add a second equation to that is not really a second equation. What it is the first equation, just a multiple of the first equation. With me?
Yep.
If I try to solve that, I'm going to get 0 equals 0. No matter what method I use to solve it. Well, this tells me that I have an infinite number of solutions. Or even if I had 3 equals 3, I have an infinite number of solutions. Because it's saying that no matter what there's lots of x's and y's that satisfy that.
Mm-hmm.
Now, let's look at the third situation where there's no solution. If I tell you x plus y equals 10, and also x plus y equals 9, if you try to solve that, you get 0 equals 1. In other words, you get one number equals a different number. Since that's impossible, that means there's no solution. Now, just as a little bit more explanation, if I were to do this graphically, when you get a solution, you have a line and you have another line, and you have a unique solution right there.
Yeah.
If you have an infinite number of solutions, you have a line, and your second line is just right on top of the first line.
Okay.
In other words, there's no intersection point. If you look at the intersection point, it's basically all numbers, right? And the third situation is where you have no solution. That's two parallel lines. They never cross. So just to help you remember, that's okay. Now let's go back and look at our problem. Says it has infinitely many solutions. Okay.
Okay.
That means that it's not a specific solution, so it's not this. Infinitely many means where one equation is just the multiple of the other. Okay?
Okay.
What's that multiple right there? The bottom
5.
equation is how much bigger than the top equation?
5 times bigger.
Okay. That means that 2 has to be 5 times A. See why? In other words,
Yes.
every term has to be 5 times bigger.
Okay.
And 8 has to be what?
5 times bigger than B.
Okay. So we know that. Now let's solve the problem. They want to know, oops, oh, Jesus. I'm sorry, let me rewrite it here. 2 equals 5A and 8 equals 5B. And they want to know what A over B is.
Mm-hmm.
Well, let's do some substitution here. Hold on. Okay, so what? A is 2/5?
Yes.
What's B?
8/5.
What's A over B? You have 2/5 divided by 8/5. How do you solve
I
that?
got 1/4, or reduces down to 1/4.
Correct. That's the correct answer. Yeah. Okay. And there is always one of these kind of problems on the exam. Every practice test I've ever seen has a simultaneous, well, it has a question about simultaneous equations, and it frequently is written like this. What causes you to have infinitely many solutions, or what causes you to have no solutions? It's almost never solved for x and y.
Okay.
Okay? So be sure that there's going to be one problem like this on the test, and it's going to be in the difficult section. So I'm not sure how much energy you want to necessarily give it, but every test has one like that. And so it's definitely worth knowing about those three types of solutions.
Good to know.
Notice that was the last problem of that section. So those last two problems are definitely the difficult ones.
Okay.
Okay. Okay, now we get to the calculator portion. Do you have your calculator handy?
Yes, I do.
I think the best way to do this is do not use your calculator when we're doing the non-calculator portions, and when you can use it. I'm not going to tell you to necessarily use it. I've long been a big believer that the calculator really does not help you on this test. Not if you're pretty good at arithmetic. There are very few questions where you actually need a calculator, and frequently the calculator will lead you in the wrong direction. I can think of numerous problems where having a calculator almost puts you at a disadvantage of not having one. But each person is different, so maybe calculator is great for you. Okay, so we're on a new section. That means it totally recycles. In other words, the first few problems are going to be easy, then it's going to get medium, then it's going to get hard. It's worth knowing that, because the very first time you look at this problem, oh my goodness, we got 7 lines of problem, and I'm looking at all kinds of variables. This looks like it would be a difficult problem. Except for the fact that I know it's problem 1. That's always going to be easy.
Yeah.
So let's see if we can figure out what it is here.
Oh, just reading the problem and everything, I decided that answer C is the correct one.
C?
Yes.
Yeah. There's the 9 cents per download, and there's the 0.002 cents for streaming. And they're added together. So, okay. Let's go down and look at number 2. What are you going to do here? What's your process going to be on this?
I would first set up a proportion, so I would put 7 over 400 and then is equal to x over 20,000.
Okay, usually on these proportions you're right. You can go either way, and I think this is probably correct, but I think you're fine doing it that way. Let me just give you a different outlook. I'm going to compare 400 light bulbs to 20,000 light bulbs. So how do I do that? How many more times 400 is 20,000? So I'm going to divide 20,000 by 400. I can do that pretty easily. 4 goes into 250 times. So we're doing 50 times as many light bulbs. So if we do 7 per 400,
then you get 350 light bulbs.
Yeah. Now, like I said, your ratio is probably going to work just fine. You did 7 over 400 equals x over 20,000. Notice we're going to end up doing the same thing. We're we're still going to divide that 20,000 times 7 over 400. So I'm still going to get the 50 from that. So even though the ratio was a different ratio, it was still correct. It's like a lot of similar triangles, and there's all kinds of ratios that seem to have that property, where it doesn't matter which ratio you choose, you're going to get the right answer, as long as you don't get it one side upside down from the other.
Makes sense.
Okay, let's look at 3. So again, tell me how you're going to do this.
Okay, so I would start off by setting 73 equal to 24 plus 3.5m.
Yeah. That's the most important thing. The rest of it's algebra. I don't even care what you get. You are 100% certain you know how to solve that?
Yes.
Let's go on. All right, now we're probably getting into the more medium questions. This one I might have to minimize so you can see it, but let's start with number 4. Number 4 and 5 are based on that statement up there.
Okay.
Another ratio problem. So they like ratio problems.
It looks like it.
So what are you going to compare first? Let's talk about this.
Okay, so I think right now I've thought of 2 ways of how to approach this problem. So the first one was based on the given information to divide 120 by 8, so then you know that each person is $15, and then you could just multiply 15 by 20 to get your answer for number 4.
That is perfectly fine.
Okay.
Also, the way I would be more inclined to do it, and I'm not sure that it matters, and I don't even know why I would mention it, but I got 8 people here, I got 20 people there. I'm going to find out that ratio.
Mm-hmm.
And then I'm going to just multiply that ratio times 120. I'm not sure that one method is superior over another. It's just how my mind works. When I see 8 people here and I see 20 people here, that's where I'm getting my ratio.
Okay.
Your mind works a little differently. You make that the ratio. $120 for 8 people, knowing that each person is $15. Almost like your method better. It's just our minds approach it a little differently.
Yeah.
Now let me see if I can get 5 on there. Also, okay, can you read that?
Yes.
Okay. Number 5. How are you going to do this one?
Okay, so I would take and I would start by subtracting 43 from 100 to get 57% because that's his profit, and then I would multiply 0.57 by 120.
Perfect. Let's go on. That's exactly the way I would do it. Number 6. You'll notice so far you haven't really needed a calculator, right?
Yeah.
Okay, go ahead. Give me the equation that this translates to.
Okay, so I have 4x plus 12 is equal to 8.
Okay. So what are you going to do as the second step?
Okay, so then for the second step, I would I would solve for x.
Good.
So I
What do you get?
subtracted. Yeah. Oh, I got x is equal to -1.
Okay, now what?
And then I translated the second equation, and I got +5.
2 times -1 plus 7. Good. You can notice that even though we're on question 6, these are still pretty easy.
Mm-hmm.
Okay, number 7.
Okay, so for this one, I would factor the equation, and I would get y is equal to x minus 2, x minus 4.
Okay, good. That's proper. Let's talk about the various formats. The most important format for a quadratic is probably this one. Y equals a times x minus h squared plus k. Okay? You're
Okay.
familiar with that one?
Mm-hmm.
Second most important one is the x-intercept format, which is y equals, same a, by the way. So the moment you see x-intercept, you're looking for an equation like that.
Okay.
And the third format, the only other one I know, is standard format, where you have y equals ax squared plus bx plus c. Usually when you're presented, and that's what this one is in standard format. Usually you're presented with a quadratic, it's in standard format. And you have to do something to get it into either vertex format or x-intercept format. And usually it's factoring it. Well, at least factoring it gets it into x-intercept format.
Mm-hmm.
Get it into vertex format, you might have to complete the square. And to be honest with you, I've never come across a problem on the SATs where you had to complete the square. It just isn't something that they test you on. But they do expect you to understand x-intercept format. So I'm trying to think, do you really even need to factor that? Notice that A is actually correct.
Mm-hmm.
It's the same equation as they gave us, but it's not the x-intercepts. I don't even have to look at that thing. This is vertex format.
Oh, okay, I see what you're saying.
This is the x-intercept format right here.
Mm-hmm.
X minus p times x minus q. Now, if you want to go to the trouble of factoring that, it turns out that this factors correctly, but I'm not sure you even need to do that. You can instantly rule out A because that's not x-intercept format. Nor is B. B may be correct, but it's not x-intercept format either. Nor is C. The only one that's x-intercept format is D. All right, let's go to 8. see if you can come up with an equation. What do you start the game with?
So I would start the game.
An equation that represents
okay.
how many points do you start? Each player starts the game with K points and loses 2 points. Here, I shouldn't label this S. I should label it P. This is how many points you have at any point in time. Okay? And what is it at the beginning? It's you start the game with K, and then you lose, subtract. What?
2 times another variable. I chose, okay, yeah, that's perfect.
Not completed. And a lot of times it's important that you do spell out your variables so you can figure out how to write the equation.
Okay.
Okay? But this seems to work. Okay? If a player who gains no additional points and fails to complete 100 tasks has a score of 200, what's the value of K? So what's the next thing I can write based on that last sentence?
Then you can set it equal to 200.
Give me the whole equation.
So now I have K minus 2n.
No, let's leave it in this format. Start with P.
Okay. So then you can make it,
This is his score.
yes. Okay. So I had it to 200 equals K minus 2 times 100.
Perfect. What's K equal to?
400.
Okay. That's very frequently what you want to do on these is write an equation that represents everything. And then they're going to give you 2 of the 3 variables. Once they give you 2 of the 3 variables, you can always calculate the 3rd variable. But try to think of equations that you can write. Okay? Now, that isn't always the greatest way to solve these. You could back solve this. But even back solving it, the equation isn't that hard to write. Let's talk about back solving it for a moment. Let's say I couldn't come up with that equation. And I didn't want to give up. So if we're going to back solve it, where am I going to start? Start with A, B, C, or D?
I would start with, well, I don't really know which one I would
start near the middle. Never start with the lowest or the highest.
Okay, good to know.
Yes, it is good to know because back solving very often is the best way to solve a problem. And let's see, and I'll show you why it makes sense to start with either B or C. I'm going to start with B just because it's an easier number. It's a lower number than C. But I'm going to start with either B or C. I'm never starting with A or D, not when they're ordered. Okay? So let's assume K is 150. Okay, well, he started with 150 points, and he lost 2 points 100 times. That's equal to minus 50, which is not 200. So I know B is wrong, but what else do I know? Do I need a bigger number or a smaller number?
That you need a bigger number.
Yes, and most of these problems are like that, where when you choose to back solve it, you're going to know whether you need a bigger or a smaller number. Now it only requires one more calculation. I do not, in other words, I'm to the point where I can cross off A, I can cross off B, and if I try C or D, I will know the answer. Now, I can try 250. Let's see if that's the answer. 250 times that, well, that's equal to plus 50. We need our answer to be 200. Now what?
So then you know that D is the answer because it's the only one.
Definitely do not do the math.
Okay.
Once you've crossed off 3 out of 4, choose number 4 and go on. One of the mistakes you can make in taking these tests is checking when you don't need to check.
Okay.
If I'm going to use back solving for this, once I've crossed off B and once I've crossed off C, I know D is the answer. I'm not sure back solving was the easiest way to solve this. It might have been, because it wasn't, it's a pretty easy equation to set up. The problem is you have 3 variables, and so you kind of have to define all 3 variables and then set the equation up. The advantage of back solving in any problem is you don't have to know what the equation is exactly. Your mind knows. So when you back solve, you can almost always set the equation up. It was easy. I didn't have to set it up in terms of 3 variables. I only had to set it up in terms of 1 variable. And that's an easier process than setting up the perfect equation containing all 3 variables. So never forget that if you can't work a problem regularly, consider back solving it. All right. Now we're looking at a problem that I would say probably is hard. Not only are there a lot of words in that stem of the question, but each answer is complicated, and we're at problem number 9. But it's not problem number 16, so it's probably not that hard.
Yeah.
We might actually be able to figure it out relatively easy. Let's have a look. Yeah, okay. We ought to be able to go through each of these answers and say yay or nay.
Okay.
X is the number of 40-pound boxes, Y is the number of 65-pound boxes, and there's 45 boxes. So which of these looks like it could be an answer?
I'd say A does.
Okay.
And possibly C.
Not C, B. In other words, the only information we're considering at this point is that the total number of boxes has to be 45 or less.
Oh, I gotcha. Okay.
So we can immediately rule that one out, and we can immediately rule that one out.
Okay.
Okay. Now, the rest of it is the forklift can carry up to either 45 boxes or a weight of 2,400 pounds. Well, what's the weight on the forklift in terms of X and Y? No matter what combination of X and Y that you put on the forklift, how much weight is going to be on it?
2,400 pounds.
Well, no, it's got to be less than that.
Oh.
Both of them say 2,400. So that's not any help at the moment. What's the equation that how much weight is going to be on that forklift?
Oh,
you got X number of 40-pound boxes. If you round up all the 40-pound boxes you have, how much weight does it have?
Can you rephrase the question, please?
Yeah. How much weight is all of the 40-pound boxes going to be? if X is the number of 40-pound boxes, and X were 10, how much would all the 40-pound boxes weigh?
Oh, okay. So if X were 10 and the 40-pound boxes, then that would mean that you have 400 pounds of 40-pound
So what
boxes.
did you do? You multiplied X by 10.
Yes. Okay.
So the total weight is what? Of the 40-pound boxes.
It'd be
Sorry, I'd give anything if I could get rid of this thing. It was
it's all right.
appearing on my computer a few days ago, and I can't figure out how to keep those popping up. But anyway, what did you do if you have 10 boxes and each one weighs 40 pounds?
You multiply.
So 40x represents the weight of all of the 40-pound boxes. What represents the weight of all the 65-pound boxes?
Gotcha. So then you would multiply 65 by the Y, or the number of 65-pound boxes?
Exactly. In other words, this is the weight of the 40-pound boxes. This is the total weight of the 65-pound boxes. And the forklift can only carry up to 2,400 pounds. So that has to be less than or equal 2,400, which is this equation.
Mm-hmm.
So A is the answer.
Got it.
Okay? All right, let's look at 10. Yeah, they definitely have increased in their degree of difficulty quickly from 6 to 10. Or I should say from 6 to 9. All right. So f of 2 is 3. F of 3 is 5. A function g satisfies g of 3 is 2. And g of 5 is 6. What is the value of f of g of 3?
Okay. So, just by looking at that one, I would say start by solving g of 3, and that gives you 2.
Start in the middle and work your way out.
Okay.
So now we have f of 2.
Mm-hmm. And then f of 2 is equal to 3, so the answer would be B.
Yeah. I'm surprised. That one's pretty easy, actually.
Mm-hmm.
I think they put it as number 10 in the difficult section because of this composite function right there. Only because of that. Because the problem isn't that hard. Okay, number 11 is the one on the right. Now, hold on a second. I'm not sure I didn't cover it up. Yeah, that should be enough for you to see it.
Yep.
First of all, don't think mathematically at all. Just look at those 4 answers.
Okay.
If you had to guess, which answer would it be?
I'd probably say B or C.
Okay. See, I'd probably say C or D. Just because he's only reading for 3 hours a day, Are you going to read a big novel in 6 days at 3 hours a day? Maybe. I don't know. But just from a realistic point of view, you might think C or D are the answer. Now, and there's so much separation there. So even if we can just get a ballpark figure, if we can figure out that it's close to 30, we know the answer. If we can figure out that it's close to 100, we know the answer. If we can figure out that it's close to 2, we know the answer. So we may have to figure it out algebraically, but this is one where you would have a good percentage guess rate. So let's talk about the strategy. How are we going to figure this out? If your life depended on it, how would you do it?
So I would first calculate how many minutes or how many words Tony can read per day.
Good, I like that. 250 words, because that matches the novel. I like that starting spot. 250 words per minute. So if he reads 3 hours a day, how many words is he going to read?
15,000.
Well, let's see. 250 times 60 times 3, right? That's equal to what?
15,000.
So that's how many words per day he's reading. What do we do next?
Okay, and then I divided the number of words in the novel by the number of words he reads per day.
Perfect. By 15,000. And it looks to me like that's probably the answer. Again, you do not need a calculator. It may look like you need a calculator, but if I'm dividing this number by 15,000, well, I can kind of do that. And what's that number? It's 20 something. It's not 324 and it's not 8. So in other words, I don't really need a calculator. If it was a grid end problem, I would. I want to do this in my head. But when I'm looking at answers that are this far apart, calculator doesn't really help. Okay, so 23 was our answer. That makes sense. You could read a novel in 23 days at 3 hours per day. In fact, if you had to guess, now that I think about it, I would definitely guess that. It's not going to take you 324 days to read a novel, not at 3 hours. I don't know how much reading you do, but it doesn't take me 324 days at 3 hours a day to read anything. So,
yeah.
Okay. 12, calculator problem. Try to figure out what they're talking about. And what would your equation be for how many tons of trash are in the landfill?
Okay, so just looking at it, I know that you start with an initial of 175,000 tons of trash, and then it increases annually.
Now, if you had to guess right now, if time was going to run out in 20 seconds, what would your guess be?
D.
Yes. It's the only one that has the number 175,000 in it. In fact, I really don't have to do much more.
Yeah, I really don't.
No, a lot of times they make it really easy on you by putting answers that are so ridiculously wrong, know that we're starting out with that amount and then we're adding to it. So it's got to be that. And if you, hold on one second. And then if you do the math, you realize that each year you're adding 7,500. So it's 7,500 times the number of years that have gone by. And if capacity is 325,000, if that's greater than or equal to 325,000, you're over capacity. Okay. Let's look at 13. That one is actually pretty easy for being number 12. So you kind of have to take some of these with a grain of salt in terms of whether they should be easy, medium, or hard. So this is a statistics problem. Interesting. I'm not sure I've ever seen a pure statistics problem on these tests. Other than asking you the mean, the mode, and the median, you definitely get questions on those. But rarely have I ever seen anything like this.
So just looking at the answers automatically, I think I can rule out population size as one of them.
Okay.
And I can also rule out the number of people who refuse to respond.
Okay.
And then I would say that it's a biased sample, so I would choose D.
D as in David?
Yes.
I agree with you. First I thought it was A.
Yeah, I did too, because that seemed like a really small sample.
Yeah, but where the survey is given is critical, because if it's given in a sports bar, you're not going to get an unbiased answer. You're talking to people that are all in a sports bar watching sports on TV.
Yep.
So where the survey is given is extremely important. Okay. Go to 14. Hold on, let me minimize that a little bit so we can get the whole thing on there. All right, that should be good. What you want to do when you see graphs, you want to know three things. You want to understand the title, you want to understand the horizontal axis, and you want to understand the vertical axis automatically. What the SAT is doing is throwing questions that would have been in the science portion of the ACT. Have you taken the ACT?
No, I have not.
Well, there's a whole section just called science. And it's about charts and graphs and tables and experiments and things like that. It's not really about science. It's about interpreting graphs and stuff. So the three most important things you can do is understand the title, the horizontal axis, and then the vertical axis. And now read that question again and see if you can come up with it. This is actually a very easy question. I'm amazed that this is 14. They're asking about which year
Okay, so I would pick C.
Okay. If we first of all find 550, that's where 550 is.
Uh-huh.
You were way ahead of me. Yeah, I like that a lot. Perfect.
Okay.
And let me add one thing, because I was looking at this whole thing wrong. I thought it was a lot easier than it was, and I would have immediately picked year 2000. Because two things I did wrong. First of all, I didn't read it closely enough. And second of all, considering it's problem number 14, it shouldn't be as easy as finding this point right here.
Mm-hmm.
And when you said C, I realized, well, this problem's a little more complicated. 550 is right there. And I'm going on the line. I'm not putting my point between the two dots. I'm going on that line that is the line of best fit. That's the
Mm-hmm.
best predictor of where it's going to be in any given year. And you're right. If I then go down to see what this point is, 2003 is the closest. And it's hard to tell exactly what that point is, but if you look at the answers, there's no question it has to be 2003.
Yeah.
Okay. That was the last. Oh, no, it wasn't. Yeah. Okay. All right, 15. So what information have they given us? What's the ratio? What is the speed in miles per year? Let's start with that.
Okay, so the speed in miles per year is 580 million.
And that is miles per year. Now, the secret is to multiply this thing by whatever you need to so that you end up with miles per hour. So let's get rid of the year. How many hours, how many days per year?
365.
So if I put 1 year in the numerator, divided by 365 days, we now have miles per day, right?
Mm-hmm.
In other words, always think of these unit problems as you're crossing off that and that. In other words, it wasn't 365 days per 1 year. It was 1 year per 365 days, and it matters which order you put them in. The goal is to cross out everything that's not miles per hour. So what do I have to multiply that by? Because right now we have miles per day.
So then you would multiply that by 1 over 24.
Yeah, 1 day over 24 hours. These ratios are either way. You make them the way that gets rid of the old units. Now we have miles per hour. So it's this number divided by 365 times 24. Now this might be one you actually need a calculator. I'm not sure I can estimate that even. What do you get? Hold on.
I
Yeah, no, there's no reason to see if I can come up with this without a calculator? Because you have a calculator. The quickest way to do it is with the calculator.
Mm-hmm. So I got A.
Okay. Number 16. Which of those 4 cells is the one for the person that did not take the review course?
The lower left. So.
Well, we have actually 100 people that didn't take the review course, right?
Oh, so you're talking about the bottom row.
Yeah, exactly.
Okay.
In other words, we need to figure out who did not take the review course. Well, that's everybody there. So that's 7 didn't take it and 93 didn't take it. 7 didn't take the review course but still passed the bar exam. But 93 didn't take the review course and did not pass the bar exam. So there was a total of 100 people that did not take the review course. Now, what is the probability that a person chosen did not take the review course?
So then it would be 1/2.
Yeah, that's what I thought. Now, since that answer isn't on there, obviously my thinking is wrong.
It's looking for somebody that passed the bar exam and did not take the review.
Oh, the table. Okay, of one of the surveyed graduates who passed the bar exam. Very key part that I overlooked. And a lot of times, if I could just force myself into underlying pieces of information that are in that stem that are key, I would do better on the test if I was to take it.
Okay.
Because a lot of times I overlook stuff like that. I completely overlook that. So if they passed the bar exam, how many people passed the bar exam?
25.
Okay. Out of those, how many people did not take the review?
7.
It's actually a pretty easy question if you read the problem correctly. But it's easy to not read the problem correctly. At least it is for me. Okay, let's see. We're in the hard part, so I don't know that starting another one is the best thing here. That might be a good place to stop. Yeah, we got a couple of more hard ones. Let's stop on 16.
Okay, sounds good.
And let me make a note that we're on 16, but it's the calculator portion. So it's 16 calculator. So there's a lot of different sections of this thing. And today is 314. When are you taking the test?
On April 9th.
Okay. Cool. Well, I think we're making good progress.
Cool. Thank you so much.
Okay. Izzy, I will talk to you next time.
I will see you then. Bye.